In this tutorial, we're going to look at the definition of yield and how to do yield calculations. So firstly, what is yield? We'll look at the definition. Then we'll look at how you do the calculations, and then finally we'll work through some examples too. Firstly, what is yield? So it's the amount of product that you get from an experiment. There is something called absolute yield, and that's the actual quantity that you obtain from an experiment. So this could be a number of grams, kilograms or moles. And there's percentage yield, and this is the amount of product you get relative to the maximum you could possibly get. So the calculated maximum that you could get from your particular experiment. Percentage yield is the one we most commonly use and refer to. It's the one you'll be asked to calculate in your exams. It gives information about how efficient or how wasteful a reaction is under the conditions we're using. So how do we calculate it? Well, percentage yield is, as we mentioned, it's the relative amount of product obtained compared to the calculated maximum. So firstly, we calculate the maximum. That's the theoretical yield if all the products react completely. And this is our equation for that. So percentage yield is the actual yield divided by the theoretical yield times 100. The 100 just to make it a percentage. So it's the actual yield divided by the theoretical yield times 100. And we have to make sure that we're talking about the actual yield and theoretical yield in matching units. So let's say we could be dealing with moles or the same mass unit, so grams in both cases or kilograms in both cases, for example. Okay, let's look at some examples. So using mass. Do you remember this example? We talked about copper carbonate and hydrochloric acid react and give copper chloride, water and carbon dioxide. So in our question, a student reacts 24.7 grams of copper carbonate with excess hydrochloric acid, and the student obtains 22.8 grams of copper chloride. The question we need to do is calculate the percentage yield of copper chloride. What's that mean? Well, it means we need to work out the amount of copper chloride as a percentage of the maximum. So I've done this little table, so we can see here we've put in the amount of copper carbonate in our experiment, 24.7, the yield of 22.8 grams, and then we've put in the molar mass of both in place as well. We've calculated that our 24.7 grams of copper carbonate is 0.2 moles. Therefore, because our copper carbonate and our copper chloride react in a 1-to-1 ratio, we know that our maximum yield is 0.2 moles. And then if we calculate the mass of that of 0.2 moles, it's 26.9 grams. But we actually got 22.8 grams. So if we divide our 22.8 grams that we achieved, divided by 26.9, the maximum, and multiply by 100 to make it into a percentage, we get 84.8%. That's our percentage yield, doing this by the mass method. We can also do this by looking at moles. So we're going to use the same example, but we're going to consider moles. So exactly the same question. And here we have the same equation, same table. We've got the mass that we've used and the mass of our yield here. We've got the molar mass of our copper carbonate and copper chloride. We already know that we had 0.2 moles of copper carbonate. We worked that out earlier. Now we can work out that 22.8 grams that we obtained from our experiment is 0.1695 moles. We just divided our 22.8 by 134.5. Our maximum obtainable moles, again, is 0.2. Nothing's changed there. We're still reacting these 1-to-1. So how do we calculate this? Well, we're dividing the number of moles we obtained, 0.1695, divided by 0.2, the maximum we could get, and that gives us 84.8%. So, in summary, percentage yield is the amount of product obtained relative to the theoretical maximum amount. And percentage yield tells us about the efficiency of a reaction or an experiment under the conditions we're using, or the wastefulness of it too. And we can use moles or mass to calculate percentage yield. So that's the end of this tutorial. Tomorrow we're going to be looking at the periodic table.